Welcome to another lecture of our data structure playlist. Today we are going to learn about the asymptotic notations we have inside our syllabus. So there are mainly three asymptotic notations which we are gonna read in our course. So the first one is BiG-O notation. Okay, we write it like this, like order of n square, like this. Okay, I have just given an example what is this and how we get this n square term. I will explain it now. So let's see, and this is the notation which we use most. Okay, that is the BiG-O notation. Okay, so see, there is a graph. Okay, there are two functions, that is f of n and g of n. So see, on the initial state there are some up downs, but at the end f of n is always less than c into g of n. Okay, that is c into g of n is greater than f of n. Okay, so that is the main part of BiG-O notation. So how we write that? See, f of n is always less than or equal to what? C into g of n. Okay, c into g of n. So we will find what is the value of this c and n, g of n. We will find that for a given f of n. So the function f of n will be given to us, and we will be finding what is the value of g of n and what is the value of c. So this g of n is will be our time complexity. So now how we will write our time complexity? As like that, order of g of n. So this g of n can be n square, log n, okay, n log n, anything like that. Okay, so now let's see for an example. We have given that f of n equals to 2n square plus n. Then we can say that f of n equals to n square. Approximately it is equals to n square. How? Because that is the order of the f of n. Okay, that is not equals to n square, it is just like that, it is in the order of n square. For the time complexity, we just take and we just consider the dominating term which is dominating over other terms. Okay, so here n square is dominating over n. Okay, so how it is dominating? For large values. Whenever we are checking time complexity, we check it for large values of n. Suppose n's value is 10 to the power 7, then the n squared term will be what? It will be 10 to the power 14, and this n will be 10 to the power 7. So 10 to the power 10 to the power 7 will be negligible in front of 10 to the power 14. Okay, so that is how we consider only the dominating terms. So how, let's see what will be the time complexity. So f of n is what? 2n square plus n, and it is given. So and we know that f of n is always less than or equal to c into g of n. So here the dominating term in the f of n is n square. So here the function of g of n will be n square. Okay, so g of n square, no, sorry. So the function g of n, here g of n will be n square. Okay, so I have written n square instead of g of n here. Okay, not here n square. Okay, so instead of g of n we will write n square. Okay, so 2n square plus n, that is fn, will always be less than or equals to c into g of n. So g of n is n square, so it will be less than or equals to cn square. So for what value of c, this value will be less than cn square. So it is already 2n square plus something extra. So c value, the value of c must be greater than 2. So it is 3. Okay, so it can also be 5, 6, you can say it can also be 6, 7, 8, anything, or this n square can also be like n to the power 5, n to the power 9, anything like that. These are also greater than this f of n. But no, for the BiG-O notation we always take the upper bound, okay, and the least upper bound. The least upper bound, what does least upper bound means? So if f of n is n square, if f of n is being n square, then we will take the least upper bound. We will not take n to the power 10 or n to the power n like this. We will just take the n square, and the value of c will be just above it. Okay, so and also this BiG-O notation gives us the time complexity of the worst case. Okay, so that is why it is widely used. We get the worst case time complexity, and I hope you understand this least upper bound thing. So if the f of n is 2n square plus n, then we will not take our g of n's value as n to the power 10 or n to the power n. Okay, like that. We will take it just the least upper bound. Okay, the least upper bound. Okay, the value will be greater than f of n, but not much greater. It will be just greater than f of n. Okay, so see, that's why our g of n's value is n square. And what I have said here, our order becomes order of g of n. So it will be becoming BiG-O of g of n was what? G of n was n square. So it will be BiG-O of n square with value c equals to 3. So this will be our value, our time complexity here, that is, or space complexity also we can say. Okay, so I will discuss time complexity now, but space complexity is also something like that. Okay, so the complexity will become order of n square. So here the complexity becomes order of n square because n square is the dominating term over others. Okay, so that is the main thing what we will check, that is what is the dominating term. So after BiG-O there is also another time complexity, that is big omega, and we write it like this. This is the sign of omega notation, and let's see from the graph again. So see here, f of n is on the upper side and g of n is on the lower side. This means what? That this means c into g of n will be less than equals to f of n. Okay, so f of n will be greater than this. Okay, so from that we can say that c of g of n gives us always the best case value or best case time complexity, and also we take the lower bound. What we are taking? We are taking the lower bound of f of n. And which is the lower bound? Just like we were having the least upper bound for BiG-O notation, here we will take the greatest lower bound. Okay, the greatest lower bound. See an example and you will understand. Suppose f of n, we can say f of n is greater than equals to c into g of n. Okay, c into g of n is what? It is big omega of g of n. So we can write that at c into g of n. So f of n is greater than or equals to c into g of n. Now let's check for the same example. So f of n is what? 2n square plus n. So it is greater than c equals to c into g of n. So g of n's value, if we take g of n's value as n square, then this will be the greatest lower bound. So here the dominating term is n square, so we will be taking the same as always. Okay, we will be taking the dominating term here, and for c into n square, and what should the value of c become, so that it is our greatest lower bound. So see, the value is f of n is 2n square plus something, that is 2n square plus n. So if the value of c becomes 2, then it will be becoming 2n square. So 2n square plus n will always be greater than 2n square. So if value of c becomes 2, then this will be our greatest lower bound. Okay, so this values of c becomes 2 and 2n square plus n is now greater than 2n square. So what is the function g of n here? The function g of n is n square. Okay, so we can write that g of n equals to n square. And how we can write the big omega notation? Big omega of g of n. So this will become big omega of n square. Okay, so here the time complexity is big omega of n square. So that is how to find the time complexity. We have now done with two main, or the two most widely used time complexities. In the next video we will be learning another type of time complexity, and now also along with that we will compare among different time complexities. So goodbye for today. Please do subscribe my channel.